So again, the key things, right, we want to remember for similarity, you're trying to find those, scale factors or being able to set the ratios or something like that, all right? Number 4, we've seen problems like this before too in our kind of like study of similarity, all right? We're dealing with the idea here, so let's read the problem. It says, the map shows a straight path from the beginning to the end of a walkway in a park. Okay, park planners want to position 2 benches between the start and finish so the 2 benches divide the walkway into 3 equal sections. So we want to find the coordinates of the second position of the bench. Okay, so we can see our walkway right here. There's the start of the walkway, there's the finish. So actually we can go ahead and we'll draw in maybe that walkway. It's a straight walkway, it said, right, from start to finish. So we'll go ahead and just draw that in. Okay, something like that. All right, and so we want to locate 2 park benches so that those 2 park benches, okay, divide this pathway into 3 equal sections. So, right, if we have 3 parts, and like if we put like a bench like right about here and like right about there or something, that will create like 3 equal parts. Okay. So, in order to divide this up into 3 equal sections, what should we first kind of try to find here? Guys, remember what we do to kind of set this up? How we kind of get this started here? The full length we can find, right? So, how can we find, for example, the full length here? We'll just measure it. So, let's go ahead and let's just measure that full length. And so let's see here. I see it to be, wow, that's nice. It's just about 3 centimeters, isn't it? That's pretty convenient, okay? So we'll go ahead and just say that that is 3 centimeters for the full length there. Okay? I measured to be about 3 centimeters. Some of you might say 2.9, okay, which is okay to say that. 2.9 is probably, bless you, I'd say it's probably closest to 3 there for sure. If I look at the measurement, yeah, that's really close to 3. Okay? And so now if I want to divide this up into 3 equal parts, what should we do? If the full length is 3 and we want to divide it into 3 equal parts, how do we do that? Yeah, just divide by 3, right? In fact, that's even easier because it's 3 centimeters. So what's 3 centimeters divided by 3? 1 centimeter. So let's just go ahead and measure then. Okay, from the starting point, measure in 1 centimeter. So about there. Okay. So that's where we should put one of the benches, is right there. Okay. And then we'll measure in another centimeter. So start from that 1 bench, and we'll go in to the second bench here. Again, about 1 centimeter. Okay, and so there's where our second bench is, right there. Now, if you look here, okay, once we've marked in that 1 centimeter, there's where the second bench is going to be, there's where the first bench is going to be. Okay, of course, we want to find the position, find the coordinates of the second position of the bench. So that's the second bench right there. Okay, but you'll notice what's kind of the problem here. It's not on a grid line, is it? Yeah, no, this is not on a grid line. So we have to kind of try and figure out which one of these 4 answers is correct. Can anyone look there and maybe can someone can we eliminate any of these that are bad that we know can't be right? I mean, for example, letter B has coordinates of 2, -1. Okay, so 2, -1, I go out, there's 2 on the x-axis, and -1 would be about like halfway there, right? Because if that's, the grid lines are counting by 2 here, right? That's 2, 4, 6, and then 8. And that's -2, -4, -6, and then -8 down there. If that's 2 right there, and then -1 would be about there, is that where our second bench is about? Yeah, no. So it can't be B for sure. All right, let's look at A. It says 4/3 and -7/3. Now, 4/3 and -7/3, that's a little bit hard to maybe think about, right? But we can convert those into decimals using our calculators, right? So we can say 4 divided by 3 is 1.333. So we'll just say it's about 1.3 or so. and then negative 7 divided by 3, that's about negative 2.333. Okay, I'll put the little lines above them there to show they're repeating. Okay. Could A be the coordinate for our second bench? Yeah, if we're going out 1 and then down 2, about 1.3, so maybe like there's halfway, a little more than halfway, and negative 2 is down to negative 2 and then a little bit more. That's the first bench, yeah, so it's not that one. So then it's either C or D, okay? So Zaria says C, let's check C, okay? Let's check. What's that, I'm sorry? You think it's C? Yeah, she thinks it's C. So let's check to see if she's right. I'm good that she's making predictions there. So 10/3 is about 3.3, repeating. And then 2/3 is about 0.6, repeating there. Thank you. Okay? So let's see here. So,
I think it's C.
I think it's D too.
yeah, if we look here, right? So let's check our answer, right? So 3, all right. There's where 3 would be, exactly halfway between 2 and 4. But we want to go out 3.3, so we need to go a little bit more than halfway. Okay. And then we have to go up 2/3, so like there would be 1, so it's a little bit less. So there's where our other point would be right there. So I think C is not quite right. It's going to be D. So let's just check D real quick. So 8/3 is 2.6, repeating, and then 1/3 is 0.3, repeating. And so we check that. Let's see here. So yeah, it's not quite 3, right? The point is just to the left of 3, because here's like the midpoint. And so it's just to the left, so that would be like 2.6, and then 0.3, it's just above there. So yeah, I think you guys are right. I think it is, in fact, D there. Okay? So again, what did we do there? We measured the full length. Okay? Measured the full length, and it was, I'm using inches, that's why it's not right. Use centimeters too, by the way, that will help you. Okay? Measure that full length. And then our benches were divided, the benches divided into 3 equal sections, so we divide that length by 3, and we place where the 2 benches were going to be by measuring in. So if it was 3 centimeters, divided by 3, it's 1 centimeter, 1 centimeter, 1 centimeter. What was the question,
Can I sit down?
Sorry, where?
Really?
Yeah, if you want to sit right there, that's fine. Yes?
Okay, it's like how you first define.
Oh, you need one.
How do we know how to do that?
How do you know how to do what?
Like, somebody explained it myself, like, I think it's stuff. Wait, when's your first?
Friday.
Like, I want to know to do that.
So the key there, Jordan, right? Okay, so it's the key to read it here. So let's read through it again, just kind of help us see. All right, it says the map shows a straight path from the beginning to the end of walkway in a park. Park planners want to position 2 benches between the start and finish. So it's a straight walkway. So we drew in that straight walkway, right? Okay. They want to position 2 benches between the start and finish so that the 2 benches divide, so that kind of gives you a clue in there, divide the walkway into 3 equal sections. So if you have a full length and you want to divide something into 3 equal parts, that's divide by 3. So full length divided by 3. Okay, that gives, so it was 3 centimeters divided into 3 was just 1 centimeter per thing. And so we just measure in 1 centimeter, that's where the first park bench has to be. Another centimeter in, first park bench. Okay? And then at that point, we're like, okay, well, this is the second one, right? If this is the start, right, there's the start, that's the first bench, that's the second bench. And we want to find the position of that second bench. And then it's just a matter of kind of like, not guessing and, it's essentially guessing and checking. You're like, could this be the coordinate? Well, we saw that 4/3 and negative 7/3 was like down here, so that can't be the coordinates. Same thing with that one, and so it was really between C and D, okay? We had to be careful there, though, because Daria was right. It was that other point was very close, okay? But D was actually the closer of the two, so that's why. You just pick the closest point that was there. That's all, okay? Does that feel more doable now?
Yeah.
Yeah, okay. So that's how we kind of connected the directions to what we did. It really is, it is hidden in there in the English. You just got to pull it out. Okay? All right. Number 5, scooting on here. Number 5, suppose triangle STR has vertices S, negative 4, 2, T, negative 3, negative 3, R, negative 1, 1. Suppose the triangle is 1, reflected over the x-axis, and 2, dilated by a scale factor of 2 with the center of dilation at the origin. What are the new coordinates of the image? Oof. Okay. So, yes, it came up.
So we already took a benchmark, correct?
Correct, the benchmark 1.
Okay, so why are we doing stuff that we learned and tested for on the benchmark 1 on the benchmark 2 test?
Great question. So we actually did, you're right, we did do like reflections in the benchmark 1 test, but dilations we did, that was after the benchmark 1 test. So I guess they feel like it's fair to ask that because it's kind of like a bit of review, you're right, with the reflection, but the dilation was new stuff we did not cover in the
Well,
whole.
reflected over the x-axis, that was
Right, that was in the past, yes. But you understand, you have to, sometimes we're going to reuse it. A reflection you should still be able to do, for sure, kind of thing. So, we're going to use some graph paper here to help us out with this one, right, because it requires using things in coordinate planes.
Need a graph, right?
So we're going to make a graph, yeah. All right?
So what happens if we don't get a good grade on it?
It's the same kind of way that a normal CRES works. It's
So,
just,
let's say I have 2 C's, right?
if you have 2 C's, then if you don't do well in the CRES, you can still pass the class. Okay? If that's what you're worried about.
Yeah, I am worried about that.
When will you show us our benchmark?
Oh, I can show you that later. Okay, maybe we're working on some class or something like that. I think I should do that. Okay, because I do have that. I just keep forgetting to, show you that. So I do have them now. All right, so let's go ahead and plot S, T, and R. So we're going to need to draw on our graph paper here. Okay, so I'm going to go ahead and just draw on our graph paper. We'll create some coordinate axes. This is for number 5. Oh goodness, you may want to make a bigger graph. Actually, now that I'm thinking about it, let me flip my paper over, sorry. We may want to make a bigger graph just because we're reflecting, or we're going to dilate. So, bless you. Bless you. So let's kind of make a big graph here. Don't be afraid to use a lot of the paper there just because I think we're going to need the space. Okay, so we use a big graph there. Okay, and then once you got your big graph there, go ahead and plot your points S, T, and R. They're just labeled right there for their coordinates. So -4, 2. There's S. T is.
How many problems are
Well, we'll see how many we fit, and if we run out, we'll get some more graph paper. So yeah, don't worry about running out of graph paper. Okay. Oh, you can't see it on the paper, sorry. And you can use your straight edge if you want to connect the dots. You don't need to, but... Okay, there's S, T, and R. Okay. And so once you got those all graphed, we'll then take a look at doing our little transformations. All right, I guess I should use a different color here so that way it kind of stands out. Let's see, do I have my purple pen? Yeah. Okay. So there's our original. Now, what is the first transformation we're supposed to perform on this shape? What's the first thing we're supposed to do here? First transformation according to the directions there. Yep. Ramel, what's that first transformation we're supposed to do? Number 5. What's it say? So, number 5. What's the first transformation? We got our triangle plotted, and the directions tell us to do what there? Number 5. Reflect it over the x-axis. Great. Okay, so Ramel, remember when we reflect, right, we just kind of like, well, here's the x-axis right here. That's the x-axis. Oops, I kind of like drew it all right there. Okay, so for example, R, how can I know where to reflect R to? If I'm reflecting over this line, the x-axis here, where's R going to reflect to? It's 1 above the x-axis, so it reflects to where? So that's a rotation. Rotation, careful. Reflection, think of like in a mirror. R is 1 above it, so it's got to go 1 below the line of reflection. If it's 1 above, we're going to go down 1, and there's
This is easy.
R prime right there. Remember that now, right? Yeah. Refreshing your memory there some. So Ramel,
I already did number.
got that one already?
Oh.
Good. So if S is 2 above, where's it going to go, Ramel? If S is 2 above, it reflects to 2 below. That's right. So 1, 2. There's S prime. And then T, where's it going to reflect to, Ramel? 3 above. Very good. So 1, 2, 3. There's T prime. Okay. Yep, we're just reflecting. It kind of, in this case, it's kind of, it looks like it's, a flip, right? Because the reflection is kind of like a flip. So we just count the distance from the line of reflection. Okay, like so. Creates like a little star-looking thing there. Okay. Just if you have like a scrap piece of paper or something like that, that'd be fine. Something you're not going to use. Okay. All right. So we did the reflection, but now we have one more transformation to do. All right. And so the next transformation we're supposed to do there is, let's see here. We're supposed to dilate it by a scale factor of 2. So that means, for example, right now T prime has its coordinates of, let's see, let me pick on someone here. So Jason, what are the coordinates of that T prime point right there?
T prime?
T prime, please, yes.
It would be negative 3 positive.
Okay, so negative 3 positive 3, so I'll write that right next to it there. Okay. You're welcome. And then what about R prime? What's R prime's coordinates?
R prime would be negative 1,
negative 1, negative 1, good. And S primes, Jason?
That would be negative 4, negative 2.
Good.
Yeah.
Nope, you're right. Okay, very good. Now, number 2, Jason, says we're going to dilate by a scale factor of 2. So that means each one of these coordinates here in T prime, to dilate by a scale factor of 2, what do we do?
Subtract 2.
Not subtract.
Oh, multiply.
Yeah, multiply, right? Multiply by 2. So T prime prime, I'm just going to write this over here to the side somewhere. So this is not the actual, actually I'll put it on the test itself. How about that? That makes more sense. So T prime prime times 2 for negative 3 is going to give us negative 6. And then times 2 for the positive 3 gives us positive 6. Okay? So that's one of the coordinates right there. Now if we look, do I need to do any more work than that? I mean, technically, yes. I need to multiply R prime.
But that's the how are you getting those numbers?
Coordinate T prime was negative 3, 3, right? We just found the coordinate of it once we reflected it. But then it said for step 2, dilate by a scale factor of 2. So we're just multiply by 2, okay? And so that's what Jason did. So negative 3 times 2 is negative 6. 3 times 2 is 6, okay? And then what about R prime prime? Well, multiply those by 2, negative 2, negative 2.
You don't have to do that though.
Yeah, truly, Ikea sees that actually after we have this first coordinate here, what's the only possible answer? It's got to be C, right? Now, Jaden, you had a question? Sorry? Where did I lose you? Dilation? So, you're okay with the reflection, right?
Oh, no.
You're not okay with the reflection.
Yeah, I don't know how to do it.
You're not sure about the reflection. Okay, so reflection. So you're okay with plotting S, R, and T, though, right? No problem. Okay, Brown, real quick. Good question.
Oh my God,
Okay, that's okay. That's okay. So S, R, and T, that was that S, R, and T, right? That's the original shape. You're okay with plotting the points for that, right?
Yeah.
Reflecting it. What are we always? When you ever have a reflection, you always have a line of reflection. Here, this is our line of reflection. How do I know? It says reflected over the x-axis. So Brianna?
So, like, with dilation, do you always multiply, we have to multiply all three, or?
Each of the 3 points, yes. But because it's multiple choice, Brianna, we only actually ended up having to do t prime times 2 because we saw that was the only t prime prime that had -6, +6 as its coordinates. These other ones didn't match up, so it has to be C. I didn't need to multiply the other ones. But you can, you should, but you don't have to. Yes, I do. Okay. So, Jaden, to reflect, if you look there, okay, like I was telling Ramel, R is 1 unit above the line of reflection. So when it reflects, it will reflect 1 unit below. Okay? F is 2 units above, so it will reflect 2 units below.
Yeah, I did that, and.
Okay, then you just connect the dots.
But it doesn't look like it.
Does it look like mine?
No, I put it.
Okay. Sorry, here you go. Okay. Let me please right word. What's up? So you got 2 below, that was right. T goes 3 above, right to there. And then, there you didn't reflect it quite far. Okay. So the answer there is C. Questions on any of that? Questions on any of that? So again, the dilation, right, that scale factor, that's what we multiply our original by to get the image, or the pre-image, we multiply by 2 to get the image. Okay? So we took those reflected points and multiplied their coordinates by 2. Okay, multiplied by 2. And if we actually were to plot these points, so if I go negative 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, and I'll put this in a different color because we are talking about a second image. So 1, 2, 3, 4, 5, 6, 6. So there's T prime prime. R prime prime has coordinates -2, -2.
Why do we have to graph it?
You don't have to. I'm just showing it to you so you can kind of see what it looks like after we have dilated, I should say. And then negative 1, 2, 3, 4, 5, 6, 7, 8, down 1, 2, 3, 4. Bless you. And there's S prime prime. Not that you need to do this, but just so you can kind of see here, there's the dilation, right? You can kind of very clearly see that it did change its size, right? What happened to the red shape to the purple shape? Did the purple shape get bigger or smaller than the red shape there? Yeah, the purple shape got bigger, right? The image, the dilation, made our shape bigger. What kind of scale factors make shapes bigger? You guys remember? What kind of scale factors make shapes bigger? Okay, but what scale factors, though? What number, what value for the scale factors? If it's bigger than 1. If it's smaller than 1, what happens to the shape? It gets smaller. Okay? So yeah, 2 is bigger than 1, Jaden, so 2 makes a shape bigger, but also like 1.5 makes a shape bigger too. Okay? Anything that's bigger than a scale factor of 1. And of course, if your scale factor is 1, what happens to the shape? It stays the same. Yeah, it doesn't change. Okay, it doesn't change. All right? So there's that. All right, let's skip on here. Made my paper a little more colorful now. And we got to skip on to number 10. Number 10. Okay, we can zoom in on this. You have a question, Ramel? Okay. Okay. So again, similarity. Okay, you can see we're talking about triangle L prime, M prime, N prime is the image of triangle element for a dilation. There's that similarity idea, right? That's how we know it's a similarity problem. It says dilation, so we're dealing with like, scale factors and all that good stuff. Okay. So, let's see what we have to do here. So, the center is the origin, and we have the original shape here, right? I know we have the original because there's no primes. It's L, M, and N, no primes, okay? And we're supposed to find the coordinates of L prime if we know that M prime, N prime is a length of 6. Okay? So the distance from M prime to N prime is 6. well, what does m prime n prime, what does this length have to match up with here in our original? M prime n prime, what does that match up to here in our original shape? M and n, okay? Now, what's the length of our original mn? The original length there, let's count it here. Ooh, okay, careful. So let's count it. Is from m to n is 1, 2, 3, 4. So it's a length of 4. Okay? So m to n is the original length, and then the image, bless you, is 6. So we go from 4, the original length there of mn is 4, and we dilate that to a length of 6. So, well, careful, when we dilate, we always are multiplying here. So that's a little bit trickier to try and figure out, right? So we have to say, like, 4 times what gives us 6?
1.5.
So, yeah, it is 1.5. Exactly right. Now, Kyle, how'd you figure that out?
Well, I just knew,
You were able to figure it out. You just saw it, yeah. Okay, and sometimes that's okay. What can we do here, folks, to kind of solve what that question mark has to be?
You can do the 6 divided by 4, right?
So we could take, yeah, both sides here. Since we have 4 times times our scale factor has to give us 6, and we'll divide both sides by 4 there. Okay, so it's 6 divided by 4, which is 3 over 2 when it simplifies, or 1.5. Either one is fine there. Okay, either one's okay. Whoops, sorry, it's off the screen. Let me zoom out.
How are you setting up something?
So you take the original, and then you take your original and you multiply by the scale factor. That's the thing we don't know. We're not sure what the scale factor here is in this case. We know that we have to go from 4 in the original to 6 in the image.
Yeah, I get that, but why are the denominators 4?
Well, we had 4 times our scale factor gives us 6, and so we divided both sides by 4. And so 6 divided by 4 is 3 halves or 1.5. Either one's fine there. So we solve for that scale factor. So basically, if we take 4 and we multiply by 1.5, we get 6. So that's our scale factor. Okay, that's the thing we're kind of using to help make that dilation happen. Okay. So questions on that? Further questions on that? Question?
Well, I don't know if there's another problem like that, but
You just want to see like how we like set that up or whatever?
yeah, like,
Whoops. So the oof. All right. So you what were you unsure about there? I guess, Jaden. Okay, the scale factor thing. So again, we have our original shape here. Okay. And for a dilation, we need kind of come up with a scale factor. Like, what is that number we're multiplying by the original to then get the image? The original, all we know about the image is that it has this m prime n prime is a length of 6. That's all we know. So what does m prime n prime match with? It matches with mn in the original, right? Mn has a length of 4. So we set up that ratio there of 4 and 6. Or we can use the scale factor. Oh, I've erased the thing there. Remember, scale factor, right, this is something we talked about. Scale factor is equal to the image over the original. Okay, in this case, what's the length of the image piece?
what are you asking?
Anybody, or you if you want to, Jaden. What's the length of the image that we know? 6. So it's equal to 6, and what's the matching original length? 4. So it's 6 over 4. So that's another way to get that, which will then give you 3 halves or 1.5. Okay, so there's a different way to do it there.
That's easier.
I'm sorry?
I said that's easier.
Good. That's good. Yeah, and that's if you because I know you remember that from last time, or you were like really good with remembering the image over original stuff from last time when we did it. Okay. So now finally, though, we want to find the coordinates of L prime. Well, I have the coordinates of L. What are the coordinates of L here? Okay, let's go to Alicia. Alicia, what are the coordinates for the original point L? And you might want to look at your paper there because mine's got small numbers. Yours probably does too, but hopefully you can read yours better. Yeah, -4, -5. Beautiful.
Times that.
So yeah, so Alicia, to get then L prime, what do I have to do to each one of these coordinates? how can I use my scale factor to get then my image? Let me refresh your memory here a little bit, right? If we took 4 times 1.5 gives us the image length of 6. So what should I do to these coordinates to get their image? Yeah, times it by 1.5. You just multiply by the scale factor. We always multiply when we're talking about images and stuff like, or dilations. Yeah, scale factor, we always multiply scale factors. So yeah. So, sorry, I'm going to zoom out. This is a skosh, so I can get the calculator on there. So negative 4 times 1.5 is negative 6. Okay, and then negative 5 times 1.5 is negative 7.5. You can't see the calculator? So we took the coordinates of L and multiplied by the scale factor of 1.5. Okay, and so it's got to be C. Okay, it must be C.
Because when I kept doing it, my calculator kept giving me 3.3.
Okay. Do you see it? Did you get it okay now, though? You might have divided by 1.5 instead of multiplying. Okay. All right, and then let's try the next one here. Let's see. That did. Yes, it did. Awesome. Okay, so the next one. So any questions on 10 before we move on there? All right, we're good? All right, let's move on here then. We'll look at the next ones, which are, 11 and 12 there. Okay. That is not good. Great. All right. So yeah, let's go to 11 and 12. Where are they? Can't find them.
Hey, what's the sign for corresponding? Or,
You just have to. You can write the word corresponding. I don't think there is a sign for corresponding. Okay. Next one.
always when you're writing a proof.
Oh, we'll get to that. We'll get to that.
Okay.
Just sorry, hang on there for a second. Okay, next one, number 11. Find the x-coordinate of n prime such that n prime is the dilated image of mn through the origin. So we're dilating here, okay? So there's m prime, there's m. So let's get the coordinates there. And again, we want to find n. N's going to be somewhere probably up in here, right? So let's find the coordinates. All right? So we're on number 11. I know, I'm sorry. It's the copy machine. I used it to staple it, and I made some mistakes. Mistakes were made. So yeah. Okay. So anyway, what are the coordinates of m here? -4, -6. And what are the coordinates of m prime? Well, they're just -2, -3. Okay? So can anyone see, what's the scale factor here? To go from m to m prime, what are we doing?
Oh, you multiply by 2.
Careful. We're going from m to m prime, so we're dividing by 2, which is the same thing as multiplying by a half, multiplying by 1/2. So the scale factor here is 1/2. Okay, again, you can think original over the image, right, for the scale factor.
I thought it was,
So original has coordinates, for example, you can say -4 over then, it's image over original. Goodness gracious, I messed up the scale factor. I'm sorry, you guys. Goodness.
That's all right, Mr. Wood. Everyone makes mistakes.
So is it 2?
Thank you. So it's, sorry, it's image over original. I messed up the order. Yeah, it's supposed to be image over original. Thank you, yes. I messed up the order. It's always image over original. It's always image divided by original. So it should be -2 over -4 is what I should have written there.
so where are you getting -2 and -4?
Shh. Guys, listen up, folks. Eyes up front. Eyes up front, guys. All right. Image is from m prime. M prime, remember, because it's got the prime, that means it's the image.
Yeah,
And
but
then
how do
m
you
zero.
use the y value?
You could have. I'll give you the same number. I'll give you the same numbers. Shh. Okay, that's 1/2. So the scale factor here is 1/2. So let's look at n. N has coordinates 4, negative 2. So that means what will n prime's coordinates be? 2, negative 1. Yeah, half that. So 2, negative 1, there's where n prime has to be. Of course, we want to answer the question, though, the x-coordinate of n prime. So what's the value we're actually going to write in here? Just a 2. Yeah, just 2.
How did you get that for n?
Because n's coordinates were 4, negative 2, right? Just that's the coordinates they had.
Right.
And so the scale factor here is 1/2. So we have to, so to get its image, we just do half of its coordinates.
What point is that?
Right here,
Yeah.
it's 2, negative 1 is the coordinates. 2, negative 1. I'll write the coordinates right there too for you.
So
2,
how would
negative.
you put that in your calculator?
Is that n?
You can do 4
Is that n? That's the way.
times 1/2, like that, for the x-coordinate, and it gives you 2. Sorry, it's an n. Yeah, it's an n. And then you can do negative 2 times 1/2. And it gives you negative 1. So 2, negative 1, their coordinates. You just multiply by that scale factor. Multiply the original by the scale factor to get the image. And so 2 is the x-coordinate. Okay?
And you got 2 how?
The scale factor, we multiply the original, 4, negative 2, by the scale factor of 1/2. Remember, take the original times the scale factor, gives you the image. 2, negative 1.
I thought the scale factor was 1/2.
It is. 1/2. Same thing. It's 2. 1/2 is 1/2.
1/2 is 2.
Multiply the scale factor. No. Shh. You take the original coordinates.
Right.
Multiply by the scale factor. 4 times 1/2 is 2.
So 4 times 1/2 is 2, right?
Negative 2 times 1/2 is negative 1. So that's how you get those coordinates. You multiply by the original coordinates by the scale factor
I
of
thought you
1/2.
were saying half of 4 is 2 and half of negative 2 is negative 1.
Yeah, that's also true. Half of something is multiplying it by 1/2. Okay? All right. Number 12 is related to that. Okay, number 12 is related to that one. Okay, number 12 is related. All right. And so, what is the scale factor for the dilation centered about the origin below that would map triangle PQR to triangle ACB? So again, in this case, we're mapping triangle PQR to triangle ACB. So which is the original here? Which one is the image?
PQR.
Yeah, PQR is the original because we're taking that and mapping it to ACB. So this is the original. This is the image. Okay. And so we'll just take a coordinate from the original, okay, and we'll take the matching coordinate for the image, and we'll do image over original. Okay, so let's just use like point P here. All right, P is a thing from the original. Remember, scale factor, because we want to find the scale factor here. What is the scale factor? So scale factor is image over original. All right. Okay, and so we need something from the image divided by a matching piece from the original. So let's yeah. So like for example, P is a point in the original or the image.
Oh, that's right.
P is from the original. So let's just pick like let's do a coordinate.
-2, 1 from A.
So give me the coordinates for P. P has coordinates -3, 1.5. Okay. And then what's P matched to in the image?
A.
P matches to A. Listen up here, folks, okay? So that's got a coordinate -2, 1. Okay? And so, from the image, A is the image here, so we can take like the coordinate -2, for example, and put it over. -2 is the x-coordinate for A, and what does that match up to in the original point P there?
Negative.
Yeah, -3. So just put -2 over -3, which simplifies to 2/3. And so there's the scale factor. It's just 2 over 3. It's just 2 over 3.
Why can't you do -3 over -2? Oh, yeah, image over
Yeah, image. Are you going to the bathroom?
Yeah.
Okay? Shh. So 2/3 there. Point for the image divided by point from the original there. Okay. 2/3.
So is that it? That's all you had to find?
And that's all from that one. Yep.
How many questions is on the benchmark?
This many, what you see right here. This is one full benchmark that you see right here. So up through 15 questions. 15 questions. But of course, there's 10 multiple choice, 2 grid-ins, and then 3 free response questions. So it'll take but it should take one class basically.
That all adds up to 15.
Yep. Yep. It should take basically one class period. Okay. All right. So we'll stop there for today.